Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
The level of the light and shade boundary depends on the shape and vertical inclination of the retroreflector. It is the latter parameter that needs constant adjustment, as the angle of inclination of the headlamps depends on the degree of loading and load distribution in the vehicle. The more the aft part is loaded, the more the front of the car will be rearward. Accordingly, even properly adjusted headlights will now blind drivers of oncoming cars. Forced action systems. The headlight corrector is controlled by changing the position of the switch on the dashboard. The main types of actuators used in the design of manual correctors: mechanical. The design can only with a stretch be called a headlight corrector, since the device is an adjusting screw, mounted in the headlight housing. Screwing or unscrewing the latter leads to a change in the vertical angle of inclination of the reflector. Hydromechanical. Electromechanical. Pneumatic. Due to its complexity, the pneumatic headlight corrector is not widely used. The system can be manually or automatically adjusted. In the first case, pneumatic actuators are controlled by the driver through an N-position switch on the dashboard, most often used in conjunction with halogen lighting. The automated system involves body position sensors, control unit actuators, used in conjunction with xenon lamps. The position of the reflector is regulated by changing the air pressure in the corresponding lines. Hydrocorrector. Domestic motorists are familiar with such a system, since manual headlight correctors of this type were installed on VAZ 2107, 2109, 2110, 2114, Niva, Granta. The main components of the system: 6. Light beam adjustment knob, 1. Main adjusting mechanism, 2. Working cylinders with a rod acting on the headlight reflector. The principle of operation is based on adjusting the position of the corrector rod by moving special fluid through the lines. The switch is mechanically connected to the piston of the main hydraulic cylinder. When the regulator knob is acted upon to raise the reflectors, the fluid pressure increases in the system, which sets the working cylinders in motion, thereby extending the rod. Since the system is completely sealed, reversing the movement of the knob has the opposite effect. The archaic system is considered extremely unreliable. Over time, tube connections and collars lose their tightness, resulting in air being sucked into the system and loss of working fluid. Electromechanical corrector. The system of headlight reflector position adjustment with an electric drive is the most widespread. The electric drive allows to realize both force change of height of the light beam boundary and automatic adjustment depending on the actual driving conditions. The device of the forced system: switch on the dashboard, gear motors, control unit, power supply wires. The switch is usually mounted to the left of the steering column and has 3 to 4 fixed positions for changing the angle of inclination of the headlight reflector. Servo drive, aka gear motor, aka headlight corrector, is an actuating mechanism, the movement of which rod raises or lowers the reflector. Resting in its lower part, from above the reflector is fixed on the hinges. Principle of operation. In principle, the servo drive device resembles the gear motor used in the design of the central locking system. Device: small magnetically excited DC motor, worm gearbox used to convert the rotary motion of the electric motor shaft into reciprocating motion of the rod. Control circuit: resistive rod position sensor. ECU regulates the rod position by supplying control voltage to the servo drive. The control logic of headlight correctors with electromechanical drive. Let's consider the example of BUK 02-01, used on many domestic cars. One of the main components of the control board is a bridge circuit control motor reducer, which is based on a 2-channel operational amplifier. One arm of the bridge circuit is connected to the actual rod position sensor, and the other arm is connected to the input pin of the control board. The effect on the electric drive of the corrector is realized by changing the control action at the input of the board. When a bridge mismatch error occurs, the control system will energize the servo drive until the voltage at the position sensor pins is equal to the control voltage. The electronic control unit necessarily includes protection against overvoltage of the vehicle's onboard network. When the electromechanical headlamp corrector switch does not change its position, the motor is in the off state. Characteristic fault circuit breakage, oxide formation in the places of connectors, wear of electric motor parts, burnout of integrated circuit elements. Automatic headlight corrector control systems. In conclusion, understanding the principle of operation of the headlight corrector is essential for appreciating how modern vehicles enhance safety and visibility on the road. By examining the various systems of automatic headlight angle adjustment, we see how these devices work in harmony with the vehicle's suspension and load conditions to ensure optimal illumination. Whether through electronic sensors or mechanical adjustments, the headlight corrector plays a crucial role in adapting to changing driving environments. As technology continues to evolve, we can expect even more sophisticated systems that further improve our driving experience and safety. Thank you for watching, and we hope this exploration has shed light on the importance of headlight correction systems.